In the previous video, we looked at the available instance types. In this video, we're going to look at the options for file system storage for our instance. We cover the available options that include local instance storage and network attached elastic block storage. Instance storage is SSD or hard disk storage that is installed in the host machine. Since it is local, you can get high disk throughput and high input outputs per second, known as IOPS. However, one big caveat is the ephemeral or temporary nature of instance storage. When your instance is running, it is occupying a slot in the hypervisor of a host server. So it has access to its share of the host machine's local storage. However, when an instance is stopped or terminated, it is removed from the hypervisor slot, and that frees the slot for another instance to occupy it. So to make sure that no one will be able to access your data, the local storage for your instance is wiped. So any data that you wrote to the volume is gone. You may be thinking that you can just back up the files before you stop your instance. However, this may not be possible if your instance is impaired, and that is the reason you're trying to stop it. So the bottom line is, don't store any important data on these volumes unless the data is also replicated elsewhere. You also don't get to directly provision the amount of instance storage that you want. You are allocated a certain amount of instance storage depending upon the size of the instance. So for example, you can see that with R3 instance types, the amount of storage can vary from 32 gigabytes for the large all the way up to 640 gigabytes for the 8x large. The two storage optimized instance types, the Ds and the Is, give you terabytes of instance storage. So then what can you use this instance storage for? Well, they're good for swap and temporary files for sure, or data that is replicated elsewhere. For example, your application can be run from these as long as the source code is stored in a source code repository and that your application is stateless, which means that the state or session data is stored in a separate storage system such as a NoSQL database. They are also fine for boot volumes, but they are not as convenient to use as EBS volumes. For one thing, you can't take a snapshot of them, and so making an AMI with instance storage requires an extra step that's known as bundling, which involves copying the files up to S3 first. Also, you cannot stop and start an instance store backed instance, because when you do, you completely wipe the boot volume, so you have to terminate them and then relaunch. Finally, AWS does not offer full volume encryption for instance storage. Because of the limitations and ephemeral nature of instance storage, AWS offers a more durable alternative, elastic block storage or EBS. This storage is not located on the host machine. It is on separate hardware elsewhere in the same availability zone. EBS volumes are attached to your instance via the network. Because of that, they have a separate life cycle and can persist even after you terminate your instance, so you can freely stop and start EBS-backed instances. To further improve the durability, the data is mirrored on two devices. Since they are network connected to your instance, you should ideally use them with instances that are EBS optimized, which will give you a more consistent disk throughput. You can provision the size of your EBS volumes however you want, from 1 gigabyte up to 16 terabytes. You can also attach multiple EBS volumes to a single instance and also RAID them if you like. However, like a physical disk drive, they can only be attached to one instance at a time. So if you need a shareable file system like a NAS, then you should consider AWS's Elastic File System service. One really nice feature is the ability to take snapshots of EBS volumes. These are very durably stored in the S3 storage service. You can restore or create new EBS volumes from snapshots. You can also enable full volume encryption, which will encrypt your data at rest and also encrypt the snapshots. The most common type of EBS volume is general purpose SSD. Because of the price drops in solid state storage, they are fairly cost effective and deliver good performance. You may remember from the previous video how T instances accumulate credits and burst when they need CPU capacity. Well, general purpose EBS volumes do a similar thing with IOPS. For volumes smaller than a terabyte, their baseline performance is 3 IOPS per gigabyte. However, they accumulate credits when operating at that level, and they can burst up to 3,000 IOPS until their credits are exhausted. Volumes greater than or equal to 1 terabyte don't need to burst because their baseline is already equal to or greater than 3000 IOPS. So general purpose EBS volumes are great for boot volumes and general instance storage. They are also good for storage for databases, particularly ones that are in development or test environments. However, if you want consistent IOPS to your EBS volumes, then you can upgrade to provisioned IOPS SSD. You can provision a consistent amount of IOPS from these volumes without bursting. The maximum amount you can provision depends upon the volume size and is limited to 30 IOPS per gigabyte to a maximum of 20,000 IOPS. There is an extra cost for the amount of IOPS you provision, so it only makes sense to use these in production environments or for things like databases which really benefit from the high and consistent I/O. Even though SSD is the new standard, AWS offers hard disk EBS volumes for a cheaper price than the SSD ones. These are optimized for sequential I/O and cannot be used for boot volumes. They offer burstable throughput similar to the general purpose SSD. The throughput optimized volumes provide a baseline of 40 megabytes per terabyte and can burst up to 250 megabytes per terabyte. These are suitable storage options for big data processing and data warehouses. Finally, the cheapest option is the cold hard disk EBS volumes, which provide a baseline throughput of 12 megabytes per second per terabyte and burst up to 80 megabytes per second per terabyte. These are good when you need large storage volumes for infrequently accessed data at the lowest price. Now that we have learned about the EC2 storage options, let's continue with the next step in launching our instance. So on step 4, we get to add storage. Notice that there is already a default root volume here of 8 gigabytes general purpose SSD. We could of course switch this to provisioned IOPS or use the cheaper magnetic storage. However, we get up to 30 gigabytes of EBS general purpose SSD storage on the free tier, so we should definitely use that. We can also add new volumes at this time if we would like, or we can add them later on. So let's just leave it at the defaults and click Next Tag Instance. Tagging instances are an optional step, and you can use them to give a name for this particular instance. So let's put Packed Training Instance as our name. And then click the Next Configure Security Group button. In this video, we discussed the storage options for EC2 instances and showed how to attach these volumes when launching an instance. So now we are ready to learn about security groups in our next video.